Right. I think that should be good. All right. So, I am doing this as a live stream because otherwise, who knows when I will get around to doing this. So, this may not be the most polished guide and software installation process because I have not dry run this. So, we shall see how well this works. All right, I need to mute that because I don't want to hear my own voice. All right. So, let's just start off with this. All right, what is Trifolium? Trifolium is um, both a PCB as well as a code base that I am maintaining um, that work hand in hand to control brushless Nerf blasters. So the PCB is RP2040 based, which is the microcontroller. Traditionally, boards like the previous board that I designed, the Spirit board, used the same chip as the Arduino Nano, which is the Atmega 328P. But to do closed loop control, we wanted to upgrade to a better microcontroller. Um, so I developed both a board and a code base that supports that. So talking about the board first, just going around the board, we have your main 8-pin connector. So this is just the here I'll show the 3D view here because that might be a little bit easier at first. So you have your USB connector, you have your 8-pin connector up here. So this typically will go to your ESC. You have two 4-pins, which these don't have models because the PCB manufacturer doesn't have a step model for that, but there's two 4-pins right here. This left one is for your OLED, and this one is for your selector. And then you have various 2-pin connectors down here for your switches and stuff like that. You have a reset button for the board right here. Basically, that just resets the board back to its initial boot up state. And then you have a boot select pin up here. And that can be used for flashing to put the board into boot select mode. I should probably have chat open as well. Okay. Anyways, okay. So that's a quick overview of the board. Otherwise, it's pretty much just a generic RP2040 board with all the USB protection, and it buck converts your battery voltage um, to board voltage. So everything's connectorized. It works pretty well. Um, the board has only been really tested on 4S, but theoretically it should work on 6S. Um, I will not guarantee that it will not blow itself up on 6S, but theoretically it should work. As for the code base, let's talk about that. So it's all on GitHub. The code base is GLP 3.0 licensed, so if you want to, fork it or whatever, you can. It's based on the Rune firmware and the LAF firmware. Um, Controller-wise, we'll get into this later too when I go through configuration, but this firmware is designed to work with either a Rune board, generic RP2040 board like the WaveShare Zero board, or some people have used, I think there's a Seed board, Seed RP2040 board as well. And then obviously it'll work with the Trifolium code as well. Right now, the code is still somewhat limited in scope, like we don't have menu support and stuff like that, but the main things that it does have is pretty decent closed loop control for your ESCs, and the firmware is also designed to be pretty generic so that it can work with many different platforms. So, for instance, say your Ophidian or your Spirit ESCs blow up, you can theoretically um, replace your ESCs with either BL 32 ESCs or AM32 ESCs, and then this code base. And then you just configure the code, and you can go from there. So that being said, let's go through, and I think I want to do. I think I will do how to connect the board. All right. So let's see here. Gather my things. So normally, hardware-wise, what you're going to need here is going to be your trigger switches. So if you have a rev switch, you'll have a rev switch, you'll have a trigger switch. This is normally designed for having a slidable, like 3-position selector switch. Later, when I add menu support, you'll also need like a button or a switch for that. But I haven't coded that up yet. I think I'll also be supporting having a button for your selector. You will optionally have an OLED, and then obviously you need your ESCs. So normally this board is really designed for 4-in-1 ESCs, which typically have 8-pin JST-SH connector. So typically it's designed for that. However, it will work if you want to use 2 single ESCs. But I think most designs now will probably, moving forward, use 4-in-1s because it's cheaper and easier. But you could either connect your 2 single ESCs up to the 8-pin connector and just wire them into your 8-pin connector, or you could use some of the extra GPIO down here and connect to the pins down there. The 2-pin connectors if you want to keep it all connectorized. But basically, I'm just going to do a quick overview of what my setup looks like right now. I have an Alpha Fencer by Bob and Tram that I have on my desk, and so let's look at that. The camera is going to be me just holding a camera, so this camera work is going to be kind of iffy, but that's alright. So here's what a board looks like, all wired up. What's nice about this is it's all connectorized. It's very small, and I mean, I've been running with this beta board. This is a V1, but for this I wanted to use the V1.1 just because more people are actually going to have this board than the other board. So it'll make a little more sense because something's changed. But basically, so we have our 8-pin connector up here that goes to my 4-in-1 ESC down here. So I want to quickly go over that. Oh, this is going to be hard to do with one hand. I did not think about that. All right. So when you get your 4-in-1 ESC, the ESCs do not have standardized pinout as far as I know. So I typically stick with SkyStars, and that's pretty much always going to be the same pinout. But they'll come with an 8-pin connector like this. And the big thing that you have to worry about is you have to be careful how you connect this, because you basically take the pins and you insert them into the connector in the order in which they should go. But let's go back to this. You have to be extremely careful about what pin you connect, because this plus pin. So we have ground, the G is ground. We have the plus, which this is 4S battery voltage. So you have to be very careful, and this comes from the ESC. You have to be very careful that you do not reverse this and insert this connector or set up the connector backwards. Because if you do, and you put 4S battery voltage into this pin instead, if you put it in reverse, it will destroy the controller. Um, so yeah, so don't do that. So that's pretty much the 8-pin connector. So the first, 4 pins here. So typically your ESC 0 or 1, depending on how I think it's indexed by 1 on the ESC. Yeah, we'll go there. And then you go 1, 2, 3, 4. Well, 1, 2, 3. And these numbers actually correspond to the GPIO of the RP2040. And then sometimes you have telemetry and ADC current. Right now, my code isn't doing anything with the telemetry because we're getting back our RPM data through bidirectional D-shot. So right now I'm not doing anything with that, but it's there if you want it. All right, so let's look back at this ESC for a second. All right, so I don't know how well this is going to show up on camera. Doesn't look like it's showing up super well. You know what? Where's my other one? All right, this one blew up, but it actually has a little sticker. So you can see it's labeled. You have ground, you have your battery voltage, ESC 1 through 4, and then telemetry and current. So that'll tell you. Otherwise, the ESC, you just wire it up. You have your positive power, negative power, capacitor. Should be pretty easy to figure out. But anyways, so once you do that, it'll look like this. You wire up your ESCs. Now, just quickly as an aside, I do think that you should sensibly wire up your ESC. So most of the time, if you're doing single stage, you typically will want to go 2 and 4 for your motors, and then I used ESC, so I'm using the ESC. This is something that you can do with AM32. I'm using the ESC to power my solenoid, and that's something new, and I'll go over that as well. But yeah, okay. And then, so let's talk about the OLED. So you have your typical SSD 1306 OLED. The connection for this is on the 4-pin connector right here. So we have C, which goes to the SLC of the OLED. You have D, which goes to the SDA of the OLED, and then you have it's actually 3.3 volts, and then you have ground. And that's it for the OLED. As for the selector, let's go back. We have our 3-pin selector. You wire in your ground to the middle pin, and then your 2 outputs to the outer 2 pins. Currently, I have it set up that you use the 9 and 10 pins and then the ground pin. So let's go back here. So I use the 9 and the 10, these 2 pins, and then the ground. If you wire it up differently, so like if you go to 9 and 8, it's not a huge deal. You just have to reconfigure that in code. But the default config is that. And then right now I'm currently using these 2 pins as the rev and the trigger pins. So let's go back here and look at that. So yep, you have 2 2-pin connectors right here for my rev and my trigger. I forget which one is which. Uh-oh. That's not good. I had something desolder itself inside my blaster while I took it apart. Okay, I'll have to fix that. Alright. Where was I? Let's see here. Which one of these is which? Green. So we have green there. So that's my rev. So on the left is rev, and on the right is my trigger. Um, Generally, you're going to want to wire in your switch to the normally open and not the normally closed. If you do it backwards, that's also fixable on code. But generally, that's what you want to do. Okay, so that being said, let's go back. Let me put this down. Put that down. And, oh, did this suspend itself? That's interesting. I'm going to try and show how to set up the development environment for this live. Hopefully that goes well because I haven't dry run this, like I said earlier. All right. So to get started, we're gonna install Visual Studio Code. This is an IDE. This is what's going to compile our code. Now, eventually, once we have menu support and everything, I would like to make it so that if people have, say you're building like a fencer, right? We could have a firmware file that you just drag and drop into the into the board, and you wouldn't have to install a development environment or anything, and then you could configure everything that you wanted on board. But we don't have that quite yet, so currently you would still need to do this. Or, you can have a friend do it. This is, my code base is designed so that the config file is the main configuration file. And so theoretically, you could just send someone your config, and then they can build the code and send it back to you. All right, so we have Visual Studio. Let's go in here, and we need to install Platform.io. So this is basically an alternative to the Arduino IDE. Arduino IDE is not a real IDE, and it's not that powerful. So this makes it much easier with library management and everything to do this. Let's not do that. All right, so Platform.io is going to install. While that's installing, I'm going to quickly solder this switch back together. Platform.io does take a while to install, depending on your system, but you should only have to do it once, so. I think I may have to install Git too, actually, now that I think about it. Okay, fixed that. Nice. Alright, while Platform.io is installing, let's just go ahead and install Git. If you don't know how to use Git, I would highly recommend learning how to use Git. It's a pretty good skill, and especially if you're writing or using code, it's very nice to know how to use Git. Visual Studio Code. That's fine. I don't care. That's fine. I'm honestly not really reading a lot of this, so. But, okay. Because I don't think anybody wants to watch me install software. So. Alright, while that's going, let's go to the Trifolium. Yeah. Let's see if it's actually Googleable. No, that's not it. Oh, I should have copy and pasted a link. All right. Well, the good news is it's on the back of the board. A little laggy. Let's see. This should get me close. There we go. All right. So we have our Trifolium code. Let's see. Is this done? Yes. Reload. So once you get Platform IO installed, you'll see this little icon. Um, once that loads, you should get other stuff too. All right, so now let's see. Do we have Git? Get out of here, Copilot. Okay, we don't have Git. That's fine. Is Git done installing? All right. So there's two ways to do this, really. If you want to use Git, you can. If you don't want to use Git, I understand. If you don't want to use Git, you can do the download zip here. So I'll just download a zip of all the code. I recommend sticking with the main branch. I may also make releases at some point if I get to that point. But otherwise, you can just do that. If you want to use Git, you can just clone using the web URL. So you can do git clone. Although actually, I think I probably should have gone into a directory because I don't know where that put that. Let's see, did I put that somewhere meaningful? Did I just put it in somewhere in my... Let's go. Where the heck are we? Okay, I don't know where that is. I think that's in... Huh? Who knows? Oh, hi, Ronan. Wow, look at all these people. Okay. I guess I'm going to be the person that does not use Git because I don't know where the heck that put that in, and I don't feel like debugging that right now. All right, so we have our code. Let's see, do we have this? No, we don't. Okay. All right, so let's open a project. Downloads, Trifolium, Trifolium, Trifolium. Okay, there we go. Trust the authors. Did that actually open the project? Oh, goodness. It's going to be upset because it doesn't have Git. Let's try restarting that. Because I did install Git. So this is one of the nice things once you actually have everything configured. These are all your libraries right here. So if there's updates to the libraries, Platform IO will pull it in. However, it's kind of annoying if it doesn't work, but looks like it's working. So right now it's pulling in all of our libraries for everything. I'll go over the toolbar, I guess, while that's going because it's gonna install everything. This is your build button, so you can build the firmware. This is your upload button, you can upload everything. Um, don't worry about the environment. There's only one environment right now, and it's a generic RP2040 board. Technically, both the Rune board and my board both have more flash. I think we have like 16 megabytes of flash versus this target only has 2 megabytes of flash. Um, so at some point I may add more targets, but I won't worry about that right now because currently the firmware does not need that much. So that's pretty much how you configure the environment. I'm going to continue this on my local machine because I don't want to have to deal with passing through everything. Um, But yeah, so now basically you would go through and go through all of the configuration stuff. So this is the main file that you want to worry about, the configuration file. Um, there is also the board config file. So if you don't, if you have your board um, and you want to reference something from the config file, so like maybe your I/O board I/O to the actual hardware pin on the board, you can go in here and you can look at what pin it is. So for instance, let's say in my current config, my trigger pin is IO1, and I want to use the Trifolium 1.1 board. So I can go in here, I can look IO1, that's pin 21. Then I can go, let's see, in here, and I can look, oh, my GPIO 21 is this pin right here. So that's a good way to look at that. This is designed for a bunch of different stuff. So for instance, like we have a rune board, so that's going to have different things than say my board because my board doesn't have a DRV. It's either designed for a FET drive, so like that would be an external FET drive board. You can either wire up a external FET to drive your solenoid, or you can use an ESC to drive it. So that's why there's two configs. Um, but yeah. All right, let's go through the config real quick. This is going to install, but we're not actually going to bother with that. So up here we have config versioning. So this is basically what I was talking about earlier. If you're sharing your config files or updating your code, if I make a breaking change to the config file, so like for instance, if I add or remove something, like remove a variable from this file, I roll the versions and then there's a runtime check that'll warn you if your config version is different than the what the version that it would expect. And that's going to prevent you from running code that's missing something basically, or something changed. All right, so let's start off here. Variable FPS. So if this is true, then you can select different RPM settings when the board reboots. So this is based off of your selector switch or selector button if you have it. Otherwise, if this is off, it just picks the first one. So this is your 4 motor RPMs. Wow, I just kind of blanked there. So it goes ESC 1, 2, 3, 4, and then this would be your next position, next position. Um, so this is where, so say I want, my board is configured for ESC 2 and 4. So if I want, I could, do I not have number lock? Why did that? Yeah, okay, so I could do like 10,000 RPM, 10,000 RPM. I don't believe I've implemented anything to error check, so if you say have a single stage board and you do 10,000, 12,000, it will try to do that and it will be probably unhappy. So don't do that. Ray, you came here for the dog. I could go get my dog. Maybe I'll text my wife and tell her to bring the dog down. But I don't know. We'll see. Maybe at the end. Okay. Dwell time. So this is the amount of time that the flywheels will stay at full RPM after releasing the trigger. And that would be either the rev trigger, or if you're running in single mode or single trigger mode, that would be your actual trigger. So that would be time at full RPM, and then idle RPM. So this would be how long to keep the flywheels idling for after the dwell time if you have it set. You can set this to 0. You can also set this to 0 depending on your preference. Eventually, I would also like to implement like a permanent idle mode, but I think that's going to come when I do the menu reprogramming thing. Spin down speed. This is in RPM per millisecond. I keep this at like 100. I wouldn't recommend going super high with this because that's going to be a lot of energy. Basically, Yeah, that'd be a lot of energy that you dissipate, and that's gonna be a lot of heat. Um, your motor kV, so this is your physical constant motor kV. So like for instance, the Kelly Plus motors are 3200 kV. This is very important for closed loop. Idle RPM, this is your um, target RPM for idling. Basically, yeah, you could you can set this higher. Like theoretically, um, if I was running like 10k RPM and I wanted to set this for some reason to like 9k, theoretically you could, but most people just set this as low as it would reliably work. D-shot mode, there is three types of D-shot. There's 300, 600, 1200. Um, I think that's just a speed difference from what I remember off the top of my head. Um, some people I think have had issues with certain types of D-shot, but I've used D-shot 300 with my stuff and I haven't had any issues. Um, keep this delay corresponding to the D-shot mode you're using. So for instance, if I was using 600, um, D-shot 600, I would change that to, D-shot 600. Flywheel control. So actually, I don't think there is open loop control. I should probably go through this config file and update a lot of this. But that's sort of why I'm making this video, is because a lot of this is kind of confusing. Anyways, right now there's two main ways of controlling. It's either TBH control, which is not, to be honest, but it is called take back half control, or PID control. Um, Personally, I think I prefer PID control now. Historically, I just fixed it recently. But historically, a lot of people have been using TBH control, but TBH control doesn't work so well when you're changing RPM. So for instance, if I had a config where I wanted to use this for HVZ, so my first selector position is set to 10K and my second one is set to 35K, um, TBH will probably overshoot relatively significantly on the 10K with the same config. Motors, so this still corresponds to your ESC. So this is motor 1, motor 2, motor 3, motor 4. So for instance, I should probably be actually filling this out. Okay, let's fix that. So if you remember, for my fencer, I have motors 2 and 4 hooked up. So for instance, I would set this to true. I would set this to true. And the rest of that is fine. Okay. Full throttle RPM tolerance. I'm actually not sure if I currently use this. Yeah, I don't think I do. I should probably comment that out too. Okay, firing tolerance. This basically controls when your solenoid will fire. So if your RPM is increasing as you spin up, and then once you get within 500 500 RPM of your target of 10K, so once you hit 9500, it would fire. Minimum firing RPM. I'm also not sure if I use that. A lot of this is carried over from DETLAF, so there are some constants in here that I don't use. Let's see. Find all references. Yeah, I don't use that. Do I use this? I also do not use that. Okay, so ignore those two for now. All right, burst length. So this is kind of confusing. This little comment blurb kind of goes over how this works. Right now we only have a couple firing modes. It's not like the Spirit where you have like, devotion and stuff like that. But in the future I would like to add those. But right now, basically if you want to do semi, you set it to burst, a burst of 1. A burst of 1 is semi. If you want to do binary, you can do binary. You can technically do binary bursts. So you can do, say I want it to fire twice at per trigger pull and release. You could do that. So these, yeah, I should explain that these two correspond to each other. Well, actually, all three of these correspond to each other. Um, yeah. And then if you want to do auto, it's, you just set it to auto and then the burst size, which that can be set to a very large number if you want, but we just set it to 100. But yeah, your options, yeah. Let's see here. What else? Oh yeah. And then say if you want to switch this, so like say I wanted auto on this as well, I could do that. But if you change that, you should also change the string because this string corresponds to this. But let's not do that. Let's see here. All right, binary trigger timeout. Yeah, so if I pull the trigger, it fires. I don't want to fire again when I release. I just keep on holding the trigger for 2 seconds, and then I release the trigger and it doesn't fire, basically. I think on my personal build I set that a good bit lower. Um, Select fire type, so you can either pick no select fire, in which case, by default, I believe it defaults to the first one of all of these things. So it would put you in auto, and it would put you in this RPM settings for your motors. Let's see here. Oh yeah, I forgot to mention these dwell times and idle times also correspond to the mode. So for instance, um, yeah, so for instance, if I'm in firing mode 3, if I'm just doing semi, I might want a higher dwell time because, I fire one shot and then I want it to stay spinning. I don't want it to have to spin back up. I might set my idle time or my dwell time a little higher. Default firing mode. So yeah, only for select fire mode. What mode to select if no pins are connected. So yeah, that is, I guess that's a little untransparent. But yeah, I would recommend just leaving this as default. Leave that as 1. So by default, it will select your first mode. Low voltage cutoff. This only takes into effect if you have a voltage divider setup, which if you're using a generic board, you would have to wire up a voltage divider setup. But if you're using a Trifolium, it does have a voltage divider. Voltage calibration factor. Um, yeah, that is also a thing. So I will explain that a little later. For your board, you have your list of different board targets that you can have. So the Pico Zero is the generic board. Pico Diana is slightly different configuration, pin configuration. And then you have Trifolium 1.0, 1.1, Rune 2.0. I plan to keep this updated as more boards come out. And then obviously for the Trifoliums, you have the ESC versus FET drive. Basically, you just can take one of these. So for instance, we want to do the FET drive, so we'll do that. Set it to your FET drive. Blaster name, this just shows up, so let's set that to Fencer. If you have an OLED hooked up, set this to true. If you don't set it to true. Rotate display, if your screen's rotated on your board or on your blaster, you can rotate it or not. Pretty self-explanatory. These are going to be your pin configs. So these IO1 and stuff, like I said, they correspond back to whatever board you're using. So the Trifolium 1.1. We go back here. This is the same config. We go back here and we can look at IO1 21. So that corresponds to your actual board. But we take those and then we plug them in here. So for instance, if I wanted to switch my rev and trigger pins, I could switch these. If I don't want to use a rev switch, I could do this and go, and then the code will adjust for that. All right. You have your selector pins. Oh, I think I was actually wrong about the, where was it? This, I believe one corresponds to this firing mode, so it would actually have been in binary and had these RPM settings. But then select 0 puts us, so basically if you can think about the selector like a button, so if the selector is in the position that this pin is connected to ground, it'll put it in the um, put it in auto, put it in selector mode 0 mode, which is auto, and then if your pin 2 select pin, yeah, select 2 pin is connected, it'll put it in semi. And then if neither of those are connected, which would be the middle position of a 3-position switch, it would go to this, which is 1. All right. Oh yeah, I should mention. Yeah, I'll talk about that later. Currently, the code is only set up for solenoids in open loop mode. So right now, this is not used, and you cannot do pusher closed loop. I think after I make this video, I'm gonna go through and I'm gonna edit this config page to actually make sense. But yeah, this we're not using right now. So for the solenoid, I do, there's an option for setting it up so that as your battery drains, the on time of the solenoid is slightly longer, so that that makes up for the solenoid being slightly weaker at lower voltages. So to do that, basically, you set your, you need a full battery, and you set your, you figure out your extend time on a full battery. You figure out your extend time on a, partially drained or empty battery. Ideally, you would want your battery to be pretty low. And then you would put your voltages for whatever the battery was at when you did your testing, and you would put your extend times when you did your testing in here. Now, normally my methodology for solenoid tuning is I do worst case scenario because I want it to be conservative for whatever I'm doing. So I use my strongest spring mag that I'm going to use, and I fully load it so that it's maximum spring pressure. And then I set my retract time really high, like 200 milliseconds. And then I slowly increase this solenoid extend time until it reliably fires. And then after I do that, typically I set up like a burst of like 3, and then I tune my retraction time until it stops firing. I go from high to low until it stops. Yeah, until it stops feeding correctly, basically, and then I increase it slightly. Hi, Thomas. So that's how that works. Typically, for neutrons, somewhere around like 25 extend time and 35 retract time typically works pretty well. Those are just kind of starting points. So these settings are if you connected your switch backwards. So normally we connect them to normally open, but for instance on my fencer, I didn't read my switch correctly and I connected it to normally closed. So you can fix that in here. Debounce time. Yeah, this is the switch debounce time. So the way it works is you press the switch, it detects an input, and then physical switches actually have something called bounce to them, where the signal oscillates between open and closed. So if you're unable to make fast double taps in semi-auto, decrease it, um, increase if you are getting accidental double taps in semi-auto. I really haven't had an issue setting this at 100 milliseconds with any of my stuff, so yeah. Um, this is unused. This is for the voltage divider. This is an averaging window. I just have it set to 1 currently. I would probably just leave it there. Pusher smoothing value, we don't use that. Alright, so let's get into, how do I want to do this? Yeah, we'll just talk about this. So, okay. So we have our TBH settings down here. We have our PID settings up here. Oh, that's interesting. Okay. The EMA filter. So this is an exponential moving average filter for your RPM. I would recommend just keeping this at 2. If you're getting a lot of noise, that's probably a hardware issue and not a software issue, so I wouldn't fix it in software. I would look into your hardware and see what's going on. Sometimes the signal wires can be a little noisy. Um, yeah, so I would keep this at 2. If you want, I think you can also set that to 1, and there will be slightly less lag in your RPM numbers, but it will not be as smooth. All right. I threshold. All right. You know, I might talk about this when I do my RPM graphs because this is going to be really confusing if I just talk about it. All right. Anyways, so then you have your P, I, and D factors. Really, I'm only using P and I for most of my setups right now. I'll go over how to tune these later. For TBH, if you're using TBH, you can just comment out this. That way you have your KI right here. And then you have your throttle cap. What did I do with that? What? Oh, I think I actually ended up not using that. All right. Wait a minute. That seems sus. I could have sworn that I did that. Something happened with my Git where I didn't commit that. That is unfortunate. That happened. Max throttle. Yeah, set up for my new controller board. This is probably more information than people actually need, but oh well. Let's see here. I really do not know how that happened. I know what that was intended to be, but I don't know why that didn't work. All right, anyways. Print telemetry, so this will print just like debug stuff out. So like if you pull your trigger, it'll print out that. I'll show you that later. And then RPM logging. So this will send out all of the RPM data from your spin up. You can change the log length if you want. You can play with that. I leave it at 2000 because that's pretty reasonable. And then last down here, you have your motor pulse. This goes back to your motor constant, which this is also very important for closed loop stuff. This has to be set correctly. So for plus motors, this would be 14. If I don't want, so after I do all my tuning, you will want to set print telemetry to false and then comment out the RPM logging. Otherwise, it will try to do both, and you will notice some hiccups when you're running. All right. So that's basically that. Let's no longer look at the VM. Let's look at my actual config. All right, so right now, my actual config, right now we're set up to 10,000 RPM, 35,000 RPM, 34,000 RPM, depending on the settings. DSHA 300, I'm using PID. I have my motors set up to true, all that stuff. ESC drive, fencer, rotate display. Yeah. Yeah, so I'm using PID right now. So, how do I want to do this? Okay, actually, let's fully close this. We can power that off. I'm not going to need that now. All right, so let's show how to flash this because that's important. All right, so I'm going to take my USB connection, USB-C, and I'm just going to plug it in the board. The board's not powered by anything but USB right now. So, okay, we have my config, and then let's go here, and you just hit this button. It finds your port. If it doesn't find your port, you may have to select it. So you just hit this button and you can select your port. However, I found it's generally pretty good about finding your actual port. So my board got flashed. So that's done. So I guess let's, I don't want to show that. Yeah, actually, let's do this. So let's show how the telemetry works. So I just changed my setting. I'm gonna re-upload. There is also how do I replicate this issue? If it doesn't find your board, you can press the reset button, press and hold the reset button, and then press the boot select button, release the reset button, and then release the boot select button, or release the boot select button, and then that will put it into boot selector mode. So actually, let me do that right now. So okay, yeah, so that worked. So I press the reset, press and hold the reset, press and hold the boot. I release the reset button, and I release the boot select button. That puts it into boot select mode, which makes it show up as like a USB drive. So you can drag and drop firmware into here, or Platform IO will pick it up again. So that's how you do that. So yeah, okay, so I just put it into telemetry mode. So then I open serial port to the board. Let's see here. I think it might actually complain about me because my voltage is low. Oh wait, it's going to be unhappy because I put it into boot select mode a bunch of times. Okay, there we go. Yeah, so it's going to be unhappy. I'm running a Trifolium 1.1. It's going to be unhappy because it has a voltage divider. Right now it's only seeing 5 volts, which is not high enough to run. So just for the moment, I'm going to switch that to 1.0 so I can demonstrate this. 1.0 did not have a voltage divider set up here. So, alright, serial monitor. Let's see here. Is that going to work? Oh yeah, it's going to be happy now. Did my other pin come loose? Oh, wait a minute. Oh, that's going to be annoying. I think I soldered that to the wrong pin again. Let me see here. Hardware debugging, yay! Normally open, normally closed. Yeah. How easy is this to pop out? Oh, no. Yeah, I can't pop that out. Okay, let me see if I can fix this real quick. I wired my rev switch wrong when I fixed it a moment ago. I need to do to a different pen, so let's fix that very briefly. Oh, the downsides of doing things live. I actually need solder. I will probably edit all of this at some point and make an actual concise video. But otherwise, you get rambling. I'm trying to solder inside of my blaster without disassembling it, which is not ideal. Okay. As soon as that stops being... Ah, there we go. Great. Alright. I think that should be good now, if I'm correct. Normally open. Wait a minute. Hold on. Okay. You know, I think the second time I wired it, I actually did it correctly. Okay, yeah, this is the issue I was talking about earlier, where it's not finding my RP2040 board. So then I just do the little thing I said to do before, put it in boot select mode, and then I try and upload again, and it uploads. All right. Serial monitor. Wait, what? Common. Normally open. Wow. Did I flip these? Open, closed, true. Okay, let's try this. Why is my rev trigger not doing anything? It's not doing the thing. Okay. Let me debug this real quick. Two port config 1.1. Let's see, what is that? Pin 18. Oh, is that why? Actually, it's this one. Pin 18. It should be that one. Which is that one? Did I like cook a switch or something? I don't know why that's being weird. Okay, well, I guess since that's being weird, maybe they're... Okay, maybe I'm wrong and there actually isn't, You know, that would make sense. Normally closed. All right. Okay. Well, that's confusing. But all right. Anyways, so I fixed that. Okay. Anyways, so yeah, you hit this button to open up your serial monitor, um, and it opens up your port. There's something else I do want to show now, before I guess we get too far into it. Uh, the other big feature of the Trifolium code base is the option for ESC pass-through. So to access pass-through, all you have to do is hold the trigger down on boot, and then as soon as it starts, just release the trigger. Which this is a little finicky if you don't have um, a screen, because you kind of have to do it based on timing. But yeah, you boot up and then you release the trigger. So let's show what that looks like here. So if you have a screen, it's gonna say ESC pass through, hold trigger to exit. So that puts you in pass through mode. ESC pass through is basically passing through your ESCs to your computer, so you can change settings. So I like am32.ca. There is also a desktop configurator. I think I have it in my downloads somewhere. Yeah, so there's also configurator tool here, so you can connect to your port. Okay, wait, hold on. You can't have serial monitor and that running at the same time, and I think that's going to mess with that. Oh boy. Okay. Lovely. Let me reboot that. Oh wait. Oh, I'm an idiot. You do actually have to have the board connected to the computer before pass-through will do anything. Ah. Okay. So hold the trigger. Turn it on. Oh yeah. Okay. There we go. So I held the trigger. The board turned on. And then I released the trigger. This is slightly easier if, yeah, it's probably actually slightly easier if you do this using the USB connection. So hold down the trigger, plug in the board, and then release the trigger, and then plug in your battery. Your battery does actually have to be connected for this to work. Otherwise, your ESC won't power on. So yeah, so then we have all of our ESC settings. So it should be noted, let's see here, I'm using the ESC config, right? Yeah, I am. So it should be noted, okay, this is mildly confusing. Let's disconnect because the web view will give a better view. All right, so how the web view works is you have your COM port that'll show up. You select that. You have 1520, or no, 1520. You have your baud rate, and then it'll connect. You hit read settings. Sometimes it doesn't read the first time, so then you just hit read again. It'll read it. So how this works is you'll have, if you have your ESC, if you're using your ESC to drive the solenoid, you need a special firmware that's different than the regular AM32 firmware. It's the AM32 experimental. It's in this GitHub. There's a release with a bunch of different hex files. You need to flash your ESC with one of these. A 4-in-1 ESC is really just 4 ESCs on one board, so 4 separate ones on one board. So you can have them on different firmware versions. When you do the pass-through and you're using your ESC, so you have your board config set to either this config or this config, your solenoid ESC will always be first, and then the next two, or however many you have, will be in order of what they are defined here. So for instance, if I have ESC2 and ESC4. ESC3 by default is the solenoid ESC, so that would be this one right here. So let's go back here. So this is ESC3 technically, but it's my ESC drive, my ESC solenoid drive, so that one shows up first. And then I have this would be ESC2, and then this would be ESC4. Typically, if I'm flashing stuff, I will change my board config to only have the ESCs that I want to actually be flashing. So for instance, if I want to flash these two ESCs, I would go back and I would just temporarily change this to FET. Alright, so I would temporarily flash this, and then only these two ESCs would show up, not this ESC, and I could flash this. That's because AM32 is a little dodgy. This website's a little dodgy with flashing the right one when you change the order of them and everything. So I would recommend doing that. Now, if you're just changing settings, I find that doing that is fine. If you have all of them, I haven't had any issues just changing settings, so you can look at different settings. I think right now I'm running all default AM32 settings. I do think that there is some benefit to changing ESC settings for flywheel applications, but I'm not going to get into that because that would be a really long video. Longer than this already is, which I think I've already been going for like an hour. Anyways, this is also really nice though. So for instance, for my board, or for my current config, I hooked up my motor and I spun it up and it span up backwards. But now I can just enter pass-through mode. I can reverse the direction of the ESC. Yeah. So this is am32.ca. I do want to show you. Let's disconnect. So when you disconnect, the board will also reboot. Or, well, should reboot. If it doesn't, you can always hold the trigger to exit pass-through mode. So I just put it back in pass-through mode because it exited, and then we're gonna go look at the experimental tool. So to access the experimental, to change the settings of the experimental firmware, you need to use the experimental PC tool. This online configurator will not work for the experimental firmware. So I do connection, and then I have my various settings. Basically, right now I have brake on stop turned on. I have stop brake level at 1. I have bidirectional mode on, and I have comp PWM on. A lot of these are default settings, but I'm pointing out the ones that aren't. Flash, this is where you could flash stuff. I'm not going to flash stuff right now. None of that's important. And then this is the important part. So you turn brush mode on, and don't forget to save your settings. It should be noted that for different ESCs, there will be different firmwares, obviously. I'm using the AM32 KM55 by SkyStar. Uh, I believe, let's see, what firmware am I currently using? I have it somewhere. I'm currently using the AM32 SkyStars AM60 thruster F 421 hex file. But depending on your ESC, you're going to want to find the right target in here. Of note, you need to match this F421 with the chip. So I do have a KM55, but my chip is the F421 and not the E230. So you can't use this firmware. It probably won't. I think the AM30 people say it doesn't break stuff if you flash the wrong firmware, but I would be careful with what you flash. Yeah, alright. So that's basically that. Hardware-wise, wow, you're driving. Okay. Hardware-wise, for the experimental drive, let's see here. You just see my solenoid wires right there, and they hook up to the pads. There's going to be one pad. Actually, I don't know if it's... So what I did to figure out which pads to connect to is I just probed it with a multimeter, and then I pulled the trigger, and I figured out which pads were which. However, I don't think it actually matters that much, and I believe you could pick any two pads. I could be wrong about that, but for my setup, I picked the middle pad and one of the outer pads, but it may depend on your ESC. Okay. What else do I need to talk about? I think that's enough of that for now. Let's talk about tuning, because that's going to be fun. Let's change this back to ESC drive. Alright. Let's talk about tuning. So let's do PID tuning first. So to do our tuning, we're going to want to turn on telemetry, and we're going to want to have RPM logging on. So let's go ahead and reflash that. What do you mean I didn't make a script? A script for this? No, I didn't make a script for this. I don't have that kind of time. I'm just doing this on the fly. Okay, so I reflashed it. I'm going to open up my serial monitor. So it's going to be getting my ESC telemetry. And then if I rev, it'll print out my RPM data. You know, I should probably talk about general other things. Alright, let's do that. I know that's very descriptive. Yeah, act like you don't. What? Yeah, I'm swinging it. Anyways, so this is what the screen looks like for this. So, it might be a little hard to see. I feel like this is a little out of focus, but there's not much I can do about that. But you have your blaster name, your profile. So it tells you, it sets your profile on boot up based on your selector position. So it'll tell you profile 0, profile 1, profile 2. That corresponds to the profiles you set up in the config file. It'll tell you your shot counter, and then it'll tell you your target RPM. So down in the corner there it says 10K. Then it says my fire mode, which right now is auto. So that's the screen stuff. Let's see. So let's go into here. Where are we? You know what? I can actually just open it here. Wait. I think that's reverse sorted. I don't like that. Okay. Trifolium. So in your wherever you downloaded your stuff, it prints your log files out to a text file. So you can copy this. I copy from the headers. So this line that says the motor all the way down to the bottom. And then I just copy that into Google Sheet that I have set up. I paste it into one column, I select the column, I split text to columns, and then that uses the commas to separate it out. And boom, we have our data. So this is what I would consider to be a pretty decent tune. I think there's some startup shenanigans that could probably be tuned out here. But I think that's due to AIM32 settings. I think it's desyncing a little on startup. But anyways, this is about what I would expect from my current code. So you see relatively little oscillations on after you reach your set point, and it doesn't overshoot too much. This is like 1,000 RPM overshoot, which isn't too bad. So let me. So all I'm going to do is reboot the board. Let's end that, reopen that. So I changed the selector. So before it was in profile 0. Oh man, I don't have that open anymore. Okay, yeah. So before it was in profile 0. Now it's in profile 2. And my RPM is now set to 34K. But otherwise, we're still using the same PID constants. So I do a spin up, prints my RPM data. I go into here. I do this. It should also be noted that like tuning this, I think will probably fall, like eventually I think people will have well-known values that work well for different setups. So like for instance for like plus motors and printed beacon wheels, like, you know, people will just be able to share their constants. But anyways, so this is what that looks like. But okay, let's go over a quick how to tune this. All right, so to start, I basically start with a very low proportional, a very low P, and my I is 0. Yeah. All right, so it just restarted. I do my spin up. It does that. I go in here, copy this out, go back to this, go back to this, go up, tune, do that. Look at my data. Huh, that actually doesn't look that bad. That's actually not what I expected to see. All right, well let's go with that for now. So you can see there's a large amount of steady state error, but otherwise that actually kind of looks okay. Maybe my constant. I honestly didn't spend a lot of time tuning this before. So let's see. All right, so actually, hold on. Let me. Why am I in insert mode? Why does my number log keep on doing weird things? I don't like that. Okay, let's do this because I would like to show you what a too low P looks like. Let's see if it actually does it though. Huh. I think my feed forward is just carrying me. Alright. Oh, that's true actually. Yeah, my feed forward is actually carrying me. Okay, so this... Let's do this then. Okay, I think this is going to be easier. So if you don't have a voltage divider, it assumes your voltage is relatively low, and what we actually do when we do PID is called there's feed forward and there's the actual PID. Um, so the feed forward assumes basically a constant throttle, and then you do your PID on top of it. And the constant throttle that the feed forward figures out is based on your battery voltage. So if you don't have your battery voltage, it can be pretty off. So this is basically, our P is very low here. So this is basically purely our feed forward. I would increase your PI, or your KP, until it overshoots slightly. And there's a lot of different methodologies to tuning um, PID loops, but oh man, it's actually I forgot to start the serial monitor. I feel like I'm not doing a great job explaining this, but that's okay. Okay. Okay, so you can see after I increased PI, my this portion up here became much steeper. So let's go back and undo that. So you can see how this gradually slopes up. That's not ideal, right? Because we want our spin up time to reach our set point time, or our set point RPM, as quickly as possible. So like right now, we're hitting our set RPM at like, what is that? Probably like 240 milliseconds. So right now, the way that the RPM logging is each entry is 1 millisecond. So this is, 240 milliseconds. That's not ideal, right? So if we go back and we increase our p-value, boom, now we're at 146 milliseconds. So that's much better. All right, so, and then, if you overtune your PI, you're going to see oscillations around your set point. So basically what you want is you want a high KP as possible without having oscillations. So let's see, that might not be high enough to induce oscillations, but let's just see. I think from what I remember tuning, I might actually, okay, yeah, so you can see this is a good example. So you can see we go above our set point, below our set point, above our set point, below our set point. So that's our KP is too high. So then you go back and forth, and you can find a nice KP value. All right, now that you found a nice KP value, depending on your setup, you might need to adjust your KI. Now, the way the I term works is a little different than how I terms generally work. So my algorithm only activates the I component of the PID loop if one of two things happens. Either we reach our set point, right? So if we go above our target RPM, I activate the I component, or if the RPM plateaus at a certain value, right? So if we're the feed forward and the proportional control is trying to reach the set point, but it can't reach the set point, right? It would plateau at a certain value. So like, your curve would go up and then it would plateau, right? That's when integration, the I value would start being applied, right? So to adjust that, this is the absolute error threshold to activate integration, right? So if this is too low, integration might not activate, right? So like, say this is like, 1. If your slope never reaches, this is basically like tracking your slope. If your slope never reaches a very low value, then the integration might never activate and you might never reach your set point. If it is too high, integration might activate too soon and cause overshoot. Just experimentally, I found this at 50 to be fine. Let's see if I can induce what I mean here. Let's go back to... The reason why I'm switching between these boards is because the 1.1 has voltage sensing. So basically kind of doesn't have some of these issues because the feed forward is pretty accurate because it's actually sensing the voltage. Okay, so let's do this. All right. So this is to show an instance in which our throttle response will plateau, and then it won't reach its set point. So see, it didn't reach our set point. Let's look at what that looks like. So as you might expect, it increases slowly and then we never reach our set point, right? If it plateaus. So to fix that, our I term is currently set to 0. So to fix that, the solution is to do detection of when it plateaus and then to start integrating. I just realized that I never really explained PID. Basically, the basic concept of PID is you have 3 components. You have your P component, which is your proportional component. So that gives you your throttle response in terms of your error. So the more error you have, the more throttle it will give it. The less error you have, the less throttle it will give it. Integration tracks the error over time, basically, and then the derivative portion tracks how fast your error changes. I feel like maybe that's a poor explanation of PID, but anyways, all right. So let's look at what this looks like. This should explain what I'm doing. Right? Okay, so our throttle response is going up. We're tracking it. We notice that it starts to plateau, so I activate integration, and then it begins to accumulate your overall error, and then, you know what? Did I? Oh, I should display that. Oh well, I used to have that displayed. And then it overshoots, and then it slowly finds its set point, right? This is not ideal because we don't want to be overshooting. So theoretically, this is just overall poor tune, right? Because before, with our p-value, we were like down here, so that's not ideal. So we would get to our set point eventually, but this overall is just not ideal. But that sort of explains what this does. But yeah, anyways, let's return to this. And then we shall we'll try our integration at 1. I think that'll be good. Oh yeah, let's reset that too, actually. It's not that. Oh man. Oh well. Okay, let's reflash that. So your I term basically, um, let's show what that does. I wish I had multiple graphs and I could show this a little easier. Right, so our I term, uh, see how this error slowly decreases and we slowly get closer to our set point. If we increase I, it's going to return to our target RPM much faster. So that's more ideal. So I want it to return to the target RPM slightly faster, so let's do that. Also, if people need help tuning PID, they can also just ask in the Discord. I will be happy to offer advice. But, so we set KI to 2 now. Let's go back. Do that. Not that. Okay, so that's somewhat better. So we reach our set point, and then it slowly, somewhat faster, goes back to our target. This is overall somewhat not optimal right now because I'm using a fully charged battery and it's assuming the battery voltage is much lower than it actually is. So tuning this is much harder than it would be if we actually had voltage control. So let's go back to voltage control. But anyways, to fix this, I might increase I even more. But a little bit of overshooting is not the end of the world. Let's go back to this and look at how this looks. Yeah. So I mean, like, this is basically perfect in my book, right? Our RPM goes up as fast as possible, and then as soon as we reach our set point, it immediately plateaus and we have basically zero error, right? Like, we have like overshoot of 100 RPM here. I mean, like, that's basically perfect, right? And we're spinning up in about 150 milliseconds. Um, I think there's some optimizations to be done over here, like I said before, with the AM32 settings. But that's pretty good in my book. All right, so that's enough of PID. Let's talk about TBH real quick. So TBH is nice because instead of 3 variables, PI and D, we only have to tune 1. So I basically start, it's been so long since I tuned TBH, but I would start low. When in doubt, start low. So let's do that. Basically, how TBH works is it's basically an integration loop. And then every time your throttle crosses a set point, it halves. Let's do that. Let's see how this looks. All right, so that looks pretty decent. You'll notice that PID or TBH is more noisy. So you see how this graph, there's a lot more spikes. That's because we don't have the filtering. So going back here, for PID, I do have this filtering, but this filtering actually adds some lag. But PI or TBH, it's extremely important that you detect your RPM crossing your target RPM as quickly as possible, so we don't do filtering on it. So that actually looks like a pretty good TBH. Let's show what a bad TBH is. So that's, the things you're looking for here are sort of similar, minimal overshoot and no oscillation. So let's throw in a bad tune. I don't know how aggressive I want to be with this because I don't. Let's try that. Okay, yeah, this is good. All right. So if my TBH is too high, I'm going to oscillate like this. And you see even the oscillation's getting worse. So that is what it looks like when TBH is too high. So when that happens, just decrease it. But all right, let's see. What else did I not go over? Super annoying. Okay, I think that's basically it. Cause let's see. Let's check. I did make a checklist, Thomas. I made a checklist of things that I needed to do. Yeah, that's pretty much it. All right. So I think that's pretty much an explanation of Trifolium. So, Ray, are you still in here? I have no idea if Ray's still in here. Let me ping Ray real quick. People wanted my dog. So I will bring my dog down. We'll get the dog camera. Oh, all right. I will return. Oh, all right. Okay. All right. Let's do this. Okay. Hi, Sabrina. All right. Ray wanted my dog. Hello. Hi there, Beans. Who's a good puppy? Oh, I'm out of breath because I just carried her down 2 flights of stairs. Hello, Beans. Look at the camera. Say hello to the people. Uh-huh. Yeah, you like sniffing on my stuff, don't you? She currently has a cone on because she tore one of her paw pads. And she likes to lick them. And that's not good for them. Needs to heal, Sabrina. Uh-huh. Yes, what a good girl. What a good puppy. This is Sabrina. She's what's called a Samoyed. They're kind of similar to Huskies, but they are very fluffy. Yeah, Thomas, you should come and see her again. She's much larger now. She's about 55 pounds now. So, you know, But anyways, okay. I think that was pretty much it. That was the overview of Trifolium and how to set it up. I hope that was a good explanation. Um, if it wasn't, feel free to DM me or ask me questions. But, yep. All right. See everybody.